Hello, welcome back to IED. Today we're going to be taking a look at Activity 3.1a, Linear Measurement with Metric Units. And in this first assignment here, this first part of the assignment, they ask us to record the lengths of these different measurements. And what I'm going to do is I'm going to go ahead and zoom in on this a little bit. And I think it makes it a little bit easier to see. Well, we can just barely see it. A is right over here. Get myself a pen that I can write with here. Come on. All right. A is going to be right here, and it's a little bit farther than 4, so I would say it's 0.4 anything. So I'm going to say this right here is 0.42. B, let me scroll down here a little bit. A little bit less than 2, but a little bit more, just a smidge bit more than maybe 1.9. So I might take this to be about 1.91. Now I've zoomed in, and I know you won't be able to see it as well as I can right now. C it's a little bit more than 3.7, not quite to 3.8. So I really don't care what you put it as. I'm going to call it 3.75. D, past 2, not quite to 3, maybe a little closer to 3. So I'm going to call it 6.28. And then letter E is out here. It's just maybe a smidge past the 3. So I'm going to call it 7.31. I don't know why that decimal point won't stay there. Alright, so I'm going to go back now to 100%. Just unzoom it. And go to the next part. Number 6, what is the difference in the length of rectangles A and C? Well, let's go back up a little bit so we can still see them. Difference means subtraction. So, A is 0.42. I don't know why these things won't stay. It's frustrating a little bit. And 3.75. Actually, it's going to be 0.42. I subtract, and I just realized my number is going to be negative, so I get 3.33, and it's a negative. All right, there's the difference between the two of them. Rectangles B and E. Now, some people, I'll go back here. Some people said, well, Ms. Kimball, difference just means, doesn't have to mean always, it can just be like an absolute value of that. And there's the saying there's a difference of 3.33 between the two measurements. And that would be acceptable as well, as long as you understand how you're going to explain your answer. B and E. E is 7.31, and B is 1.91. So when I subtract, I get 0, borrow from the 7, we get a 6, 4, 5. And again, you could say that's negative, or you could say the difference is just, oh, I don't know what, that's interesting, let's get rid of that. There we go. Sorry about that. Sometimes things pop up on our computers that we can't control. So someone might say it's also just a difference there of 5.4. Now, number 8 tells us, and what I'm not worried about this, is the significant digits. But we do want to include the correct units. So I'm going to do it right here, the same way that I'm asked you guys to do it. You won't be able to see the ruler that I'm putting on here, and I'll probably speed it up here a little. Number 1 up here I measured to be a little bit more than 10.4, so I'm going to say 10.43. 2, as I measure it, I get about 6.21. 3, as I measure it, I get about 5.29. These would all be with the correct units. Yours could be a little bit different because we're measuring off computers, and I know I've got some older kids that have a different computer screen or monitor screen than what my freshmen do and sophomores. So we're all going to get a little bit different measurement right here. This right here is going to be 1 point, I'm going to say 55. But one thing we should all have in common, though, is the units. Now 5, that little symbol right there is the diameter. So what that tells me to do there is to measure all the way across. And as I do that, on mine, I'm going to get an answer of about 1.05 centimeters. That was number 5. Number 6 down here tells me to find the radius. And I'm going to say that this right here was 2.47 centimeters. Number 9, measure and record the linear measurements of items in your classroom. Use appropriate metric units as directed by your instructor. Create this chart in your engineering notebook and record the measurements. So, what I've got here then is the first thing here is a CD. The measurement, when I did this, I found it to be 12.03 centimeters. Luckily, the unit they want me to write it in is in centimeters, so I don't have to do any conversion. The table height, I was finding height, and I found it to be 71.58 centimeters. They want it in millimeters. Millimeters is one spot to the right, so I need to take my decimal then and move it one spot to the right, and I get 715.8 millimeters. CPU width, well, if you haven't started to catch on yet, we're measuring the width. I measured it to be 30.49 centimeters. They're wanting it in kilometers. And kilometers is 1, 2, 3, 4, 5 spots to the left. So I need to take my decimal and move it 5 spots to the left. 1, 2, 3, 4, 5. I fill in with zeros and I get 0.0003049 kilometers. Not a very big measurement. The last thing here is the depth of a table tray. And I've already measured that one, and I got that to be 13.41 centimeters. They want us to convert that to nanometers. That is 1, 2, 3, 4 spots to the right. So I'm going to move my decimal 1, 2, 3, 4 spots to the right. That becomes 1, 3, 4, 1, and then I add 2 more zeros onto it. Nanometers. And that right there is depth. As to what I was measuring. Number 10. In your notebook, create a full-scale isometric view of the object represented in the following sketch using the dimensions shown. Use a metric ruler to obtain the correct dimensions on your sketch. Alright, I've been working for this now. One of the things I'm pulling up here, as you might be able to see, some isometric paper on Word. So I'm going to be flipping back and forth as I do this. So as I look at my assignment here, right down here is my point. This is where I'm going to make this whole box. And they want me to do it using a ruler, not using the boxes now. So I'm going to go back to my isometric grid paper. And hopefully, now, let's pull up the pen. Right, pens. I should be able to start to draw this using my ISO paper here. Alright, I'm going to start here then. Get my pen back here. I'm going to start by putting a little point right there. And I find out that it goes back 2 centimeters and it has a height of 5 centimeters. So again, I've got to go up here and click on this. I'm going to start with the gray, and I'm going to simply just be making the box for this. So I'm going to go back 2 centimeters, and then it's going to go up 5. So I'm simply putting my ruler down. You can't see this, but I'm measuring back 2 centimeters. And where it finishes now, I'm going to go up 5 centimeters from here. So what I'm doing is I'm creating this front view. So that right there is the first 2 parts of that. Now, this is going to encompass the whole front view of my box. So what I'm going to do now is I'm going to measure up 5 centimeters here. And then I'm connecting these two. Oh, it's interesting how that keeps going back and forth. It makes life interesting a little bit for us. How it keeps changing the view there for us. And there, what I've drawn there is the front. So I've drawn this side of the box. Now I'm going to draw is the left side here. That's the 3.5, and the good thing is it's still going to go up 5. So hopefully I cannot touch anything here again, and it won't go bonkers on me again. There's 2, 3, 3.5, and then I'm just going to cheat a little bit here because I know that's already be 5 centimeters. And I'm just drawing that line up, and where this line ended, I know that it has to go straight up. And then I can go over here and cheat, cheat, cheat. Go over here and cheat, a little cheat, cheat. Sometimes I like to make songs while I'm doing this. There's the box for this isometric view. So I've got the whole box. Basically now what I've got to do is cut this part out. Well, I know this to be 2 centimeters here. I know this part right here to be 1 centimeter. So I'm going to cut out this portion right here. This is 2 centimeters up and it goes 1 centimeter over. So what I'm going to do here now is I'm going to go up 2 centimeters. From here I'm going to go up 2 centimeters and make a little mark. Then I go up 2 centimeters and make a little mark. And where those two intersect now, and then I also move this one over 1 centimeter. So I'm going to put my ruler here, go over 1 centimeter, and where all of these lines intersect now, not perfect, but pretty gosh darn good. This tells me now that this becomes the section that I'm going to be cutting out of here. This section right here is the part that's going to be gone. Now, not all that's going to be gone because I still have one more part of that left. I have this back piece that I've not put on there yet. What I know here then is that this goes back 2.5 centimeters, and it's I believe they're wanting us to know that this is up 1 centimeter. That those are supposed to be the same measurements. I'm not exactly sure that that's real obvious, but again, it goes back 2.5 centimeters, and then that's 1 by 1. So let's go back to that ISO paper. It goes back 2.5 centimeters. There's 1, 2.5. So there I went back and made my mark at 2.5 centimeters. And I'm going to hit that button again. And then I know that it's supposed to be, I think, 1 centimeter by 1 centimeter. So I'll go back and put it back to 75 again. And 1 centimeter up. And what that tells me then, if I withdraw my line up, but that's that back picture. Now, again, doesn't look perfect. I made a few mistakes here, but what I'm going to do now is I use gray to represent the light lines, and I can't really do light lines on a computer here, but I can now come back with black and make my object lines, and that's what I'm going to do. And what I'm trying to get some of you guys to realize there is when you do this, you don't have to erase, because automatically, even though the gray lines are there, your eyes are naturally, they will naturally go to the object lines. And so if I go through here and really start to make some of these lines really dark, where the object lines is, it's as if the gray lines were never even there, because your eyes automatically just start to pay attention to the really dark ones. And the gray, it's almost as if it's been erased, because all your eyes really perceive then is the really dark object lines. You don't have to spend time erasing. So there it is. Hey, I hope that's been some benefit to you. Because I'm going to real quickly look at this. Remember, I didn't care about this meaning of significant digits or measurement. That question I said you didn't have to deal with. So down here, why is the metric system used instead of the U.S. customary system and vice versa in various parts of the world? Well, the main reason here in the United States is because people are used to the U.S. customary system. You guys are one of the first generations of students who are becoming more and more comfortable with the metric system. And hopefully we'll be able to make that jump here soon, because it is holding us back a little bit when it comes to world and commerce financially. We have more and more people who are moving into the United States who already know the metric system. As you know about the people in your class who are much more comfortable with it than you are. So that's one of the reasons that we're trying to move to the metric system. Why then do they use the metric system instead of the customary system, let's say in Europe? Well, because in Europe, if everybody's on the metric system, then all the units are similar. A meter is a meter, a centimeter is a centimeter, a gram's a gram, a liter is a liter, and whatnot. One of the problems we do have over here is there are some differences in what we consider in our measurements. Trying to think of something, for example, between our country and other countries. We may call it the same thing, but it's not the same units. For example, like ounces. We use ounces for volume, and we also use ounces for weight. So it's very confusing at times. So hopefully that helps you answer that question a little bit with some detail, and I'll see you on the flip side.